Assalamu alaikum and hello everybody, welcome to Mathsable. Today we will be doing arithmetic and geometric progressions and or sequences. This chapter mainly consists of finding the nth term or the unknown terms using the sequences formulas or the sum of a certain number of terms. So let's start with arithmetic progressions. Now the first term of any sequence, whether it's arithmetic or geometric, is always equal to term 1, or you can denote it by a as well. Moreover, the difference between the next and the previous term is d, or we can say term 2 minus term 1 is equal to d. Keep in mind the difference throughout the arithmetic sequence remains constant, or you can say it is common. N is the unknown term or the number of terms to be added. It depends on the question or the statement. If it's asking for the sum of n terms, n is the number of terms to be added. If it's asking for the Tn, which is term n, n is the unknown term which you need to find out. Let's move on to our first formula, which is the nth term is equal to a plus n minus 1 times difference. For example, here we have an arithmetic sequence 34, 37, 40 and 43 and so on. They're asking us for the common difference and the 50th term. So we will use the formula of the common difference, which is term 2 minus term 1, or in this case 37 minus 34, and we get plus 3. To find the 50th term, we would use the formula Tn is equal to a plus n minus 1 times d. So term 50 is equal to a plus n minus 1. A here is 34 plus n minus 1. N is 50 minus 1 times the common difference, which is 3. After simplifying it, we get 147. So 49 times 3 plus 34 is equal to 181. The next formula, which is the sum of n terms, and that is equal to n over 2 times 2a plus n minus 1 times d. Let's use the same example to find out the sum of the first 6 terms of this arithmetic sequence. So here n is 6 is equal to n over 2 times 2a is 34 plus n minus 1, n is 6 minus 1 times the common difference, which is 3. And after you have simplified it, the answer is 249. So 249 is the sum of the first 6 terms in the sequence. And we're done with the arithmetic sequences. Let's move on to the geometric sequences. So similarly, the first term of any sequence is term 1, which is equal to a for geometric sequences as well. The ratio, however, between the next and the previous term is equal to r, we denoted by r, which is equal to term 2 divided by term 1. And keeping in mind the ratio between every term in a geometric sequence also remains constant, or you can say the ratio is common. N is again the unknown term or the number of terms to be added in a geometric sequence as well. Now the nth term formula is Dn is equal to a times r power n minus 1, where a is the first term, r is the common ratio, power n minus 1. For example, there is this geometric sequence, and they're asking for the common ratio. The common ratio is the second term divided by the first term. So 6 divided by 3, and it turns out to be times 2, which is the common ratio. And the 10th term would be, we would use the same formula. The 10th term is equal to ar power n minus 1. A is 3 times r, which is 2, power n minus 1. N is 10 minus 1 is equal to, so 3 times 2 to the power 10 minus 1, so 2 to the power 9. 2 to the power 9 is 512, so times 512, which would be 1536. So 1536 is the 10th term of this sequence. The next formula, which is the sum of n terms of a geometric sequence, is equal to a times 1 minus r power n whole divided by 1 minus r. So using the same example of the geometric sequence, we will find the sum of the first 5 terms of the sequence. So sum of the first 5 terms is equal to a is the first term times 1 minus r is the common ratio, which was 2, power n is 5, whole divided by 1 minus r. So 3 times 2 to the power 5, which is 32, 1 minus 32 minus 31, divided by minus 1. This would be equal to minus 93 divided by minus 1, so minus would get cancelled, and the sum of the first 5 terms would be 93. Finally, the sum to infinity, or the sum of n terms only when the ratio is greater than minus 1 and less than 1, is equal to a over 1 minus r. For example, in this geometric sequence, the ratio is less than 1, hence 0.5. So the sum to infinite terms would be a is 12 over 1 minus r, the common ratio is 0.5. So 12 over 0.5 would be 24. We are now done with arithmetic and geometric progressions. Hopefully you found this video to be useful, and on that note, have a great rest of your day and Assalamu alaikum.